First, we'll start with a disclaimer. The following narrative is a work of pure fiction. Any similarities to actual people, places, or events are entirely coincidental and absolutely unrelated to the speaker's professional life. Furthermore, the speaker categorically denies any emotional attachment to animated films featuring entrepreneurial insects. This statement has been notarized by the Ministry of Totally Serious Bugs. It's 9:35 a.m. on a Monday morning. 57 floors above the relentless pulse of New York's financial district, it was just another day at Ant Intelligence, a leading market data provider. The air was thick with the scent of fresh coffee, and the relentless crackling of mechanical keyboards resonated the open plan office. Slim, from L1 support, had barely taken the first sip of his coffee as he notices an alert on the Slack channel. Goldman husks, Hopper, GH.com, dashboards are not loading. Goldkern Husks is the biggest commodities trader on the street. Hopper, their top boss, is a legend in the industry. He's not known for his patience. His name sends chills through all of L1 support. Slim scans all through his old notes, old Jira tickets, and 10 minutes after frantically searching for dashboard outage, empty dashboard, he has nothing. He tags the UI team in desperation. All GH dashboards are down. Search Confluence, Stack Exchange, ServiceNow, Runbooks. Need someone from the UI team to take a look. Dot, the incident manager, jumps in with 100 questions. Is it just one client? How many users have been impacted? Any screenshots? Did you do a screen share with the user? And she tags Rosie and Atta. Rosie is the lead developer on the UI team. And Atta is the product owner. Rosie responds with even more questions. Did you ask them if they have cleared their browser cache? Are they even using a supported browser? It could be their firewalls that are blocking the web sockets. Slim takes a deep breath and reaches out to the client on Zoom. After 10 minutes of back and forth, he finally has the answers, and he sends them to Rosie. Now, he has to deliver the bad news to the whole team. Okay, checked with the client, all good on their end. Hopper is escalating this as the 15 minutes SLA has been reached. This frustrates Rosie. Slim has nothing useful for her. I have been looking through the screenshots and logs. It's just third-party libraries, errors. I've been asking the team to clean this up for weeks. Atta has even more bad news. Hopper has escalated this to Ant Intelligence execs. We need coordinated updates. Why is our status page still showing healthy? Can the SRE team please check? Manny, the SRE on support, has been secretly lurking on the chat and jumps in. Let's calm down here a bit. Health checks are passing. All pods are healthy. No crashes anywhere. Rosie loses it. Her team will be blamed for this. But it must be the backend team like last time. I'm sure the C++ team released over the weekend without telling us, Atta, why is no one from the C++ team here? Slim incidentally knew the answer, as he had reached out to them before. Everyone is at CPBCon this week. A few minutes roll by, and Manny sent some replies. There were no releases. I checked Argo CD, but something is interesting. The processor pod logs have a JSON field, rose red, it's 0 on every field. Right then, more bad news comes along. Any progress yet? What's the ETA on the fix? Atta is desperate now. This is all hands on deck. Flick, what is Manny saying? Can you check the on-prem Airflow cluster? Flick is always plugged into Slack. He types in checking, but does not send the response. Instead, he checks the Datadog dashboard for his Airflow cluster. Just as he suspected, the nightly ticker load batch job has not completed yet. It should have been completed before the markets opened. Looks like the nightly ticker job has not completed. It's stuck for 15 hours. Generally, it gets done in 5 hours, trying to find out what's going on. Another 30 minutes scroll by. Yes, Flick has done it again. Found the bug that caused the outage. He quickly replies, I think I found the smoking gun. The disk where the job is running was full, so it's crashing, but it keeps failing silently and retrying. Manny says, but we received no disk pressure alerts. Sim replies, this disk is kept clean by a cron job that runs on the host itself, and there is no disk pressure alerts. I've cleaned it up manually and rerun the job with more workers. Now it should be done within a couple of hours. I can explain during the postmortem. Later, during the postmortem, he took the center stage and explained what he had found. I think I found the smoking gun. Recently, we got a huge performance boost from sharding the ticker file. So instead of one large file, we now write multiple files for dates and exchanges. Unfortunately, the cleanup job that removes the old files was in a different repository, so our copilot missed it, and we could not get it fixed. That resulted in more files getting generated and not getting cleaned up, eventually filling up the disk. So I just vibe coded the patch, pushed it to prod, so we can call this a day. Manny, the SRE, looks at Slim and asks, your patch has fixed the bug, but what else needs a patch? Slim pauses and thinks for a moment and asks, what do you mean? I've deployed the fix. The dashboards are back up. What else needs a patch? Anybody else in production support roles? Maybe have done production support before? Does this sound familiar? I'm incidentally on production support this week, so I'm hoping this does not blow up on my face. So I work as an engineering manager at LSEG in the low latency engineering group. And this talk is some learnings that I have had over the period of years working there and at other places. I've been a developer all my life, so I used to create bugs before. Now I ship others' bugs. So this has given me a front row seat to a lot of crisis outages. And every time when I'm inside a postmortem, I ask myself, the patch has been deployed. The bug has been fixed. But what did we learn from this bug's lifespan? What else needs a patch? So we will try to answer these questions in 4 steps. First, we will see why it is necessary for us to change our attitude towards bugs. Then we will try to measure where we are today. And then we see what needs to be changed. And lastly, we'll try to find out how to enact that change. So the new normal, why do we need to change our attitude towards bugs? So how does bugs make you feel? Anybody excited when they get a bug report? I don't see any raised hands. So bugs generally have a sense of loss associated with it. It's a loss of value to the customer. It's financial loss. Knight Capital, one of the saddest story about bugs probably, after being operational for 17 years, ended in under an hour because their configs had some errors. $440 million were lost. Equifax, 150 million Americans had their sensitive information released because of a security bug that was not patched. Loss of human life, 346 people died because of a bug in Boeing 737 software. Now, all these stories have resulted in a sense of blame. So bugs now really mean blame. It hurts our personal pride. It hurts our ownership. It hurts our craftsmanship. Even our favorite tools use language that have blame in them. But you can ask me, hasn't this been always the case? Yes, it has. But things are changing. We're now at a strategic inflection point where we are seeing more code getting written than ever. All the major AI vendors, they're selling us their tools, which lets us write code faster. If you see here, all the CEOs are telling us that we are writing code with AI agents. Why aren't you writing code with AI agents? Don't get me wrong, I love vibe coding. I love writing code at the speed of thought. But it's the debugging part that concerns me. When you have bugs in production, when they show up, then if it's not your code, it makes life a lot difficult. And then we ask the question, where does this blame stop? Does it stop with the author? That is what we are used to. Now we are being told that code will be written by the agents, and we will be in the position of a reviewer. So does it stop with the reviewer, or does it stop with the agent itself? If you think this is too far-fetched, this is just from last week, when an agent deleted the entire database during a code freeze and action freeze. And it was very upfront about doing this problem. And Replit CEO had to come and say that he had to apologize for his agent doing this. So we need to change our mindset at this point. We need to see bugs as not a blame game. We need to see them as opportunities to plug gaps. We need to see them as not personal failures, but learning checkpoints. Not as an occasional damage control mechanism, but we need a disciplined approach towards debugging. So now we know the why. Let's talk a little bit about where we are today. As developers, we love our metrics. We love measuring things, because we know if you can't measure it, you can't improve it. We love our code coverage. We love test pass rate, cyclomatic complexity. But maybe for this age, those are not just enough. We need more metrics. I'm going to briefly talk about some more metrics that's very popular in the DevOps world and why we need to put our attention towards that. So DORA stands for DevOps Research and Assessment. So the first metric that we are going to look at, deployment frequency. If, of all the 4 metrics that we are going to talk about, if you have to zoom in on one, this is probably my favorite of all of them. So one metric to rule them all. How fast you are deploying to production, that determines a lot about your code base, your architecture, your team, everything. If you go a little deeper, then comes the second metric, your lead time for change. Why can't you deploy faster? Are there too many manual steps in your deployment? Are your builds too slow? Are your test executions taking a lot of time? Are you stuck in too many approvals? Is your architecture, is it having some limitations because of which you cannot do zero downtime deployments? Or maybe you are in the high performance category. You can deploy very fast. But what about your upstream and downstream? In today's world, we are no longer building software in isolation. It's a team sport. You are playing with multiple stakeholders. And your upstream might not be in the same position. Everybody has their own backlog. It's prioritized in a different way. And your emergency is not their priority. Then change failure rate. This is the third metric that we are going to talk about. How often does your change result in a failure? What does this tell us about? This allows us to ask questions. Are there areas in your code base that have too much technical debt so that when you're trying to release a hotfix, it's really difficult to do the refactoring? Are there gaps in your testing pyramid? Maybe your unit tests are all passing 80% coverage, more than 80% coverage, but your integration tests take a lot of time for spinning up, so people are not really using it. Are you adding new tests every time a bug gets patched? Are your regression tests too flaky? Maybe your pre-prod environment is not as close to your prod environment as it should be. And between this rift, bugs hide. Configuration bugs can sit in this rift, which will show up in production. Or what about the test data? The velocity, variety, and volume. Are they accurate representation of what you have in production? And lastly, how fast do you bounce back? Is your support person drowning in alerts? Are your runbooks, support rotation schedule, your upcoming releases, are they all up to date? Are there knowledge gaps in your team? I cannot tell you how many times I've had situations where I need to work with somebody and they need to access a system, but they do not have access to that system. And during those precious moments, we're trying to figure out how to give access to the system so that they can check if a job is running, if a job has failed. All these take away very important time and increases your time to recover. And then lastly, key person risk. Are there people who might be at a conference? What is their backup for that? What's your plan for that? And what's really important during such high crisis moment, are your team members feeling safe? If they're not speaking up, it's yet another disaster waiting to happen. So 4 metrics: deployment frequency, lead time for change, change failure rate, and time to restore the service. If you were to take just one thing from this talk, it would be focus on your deployment frequency. The rest of it will slowly come. There's also another metric called reliability, but zooming in and taking deployment frequency as your North Star, I think that can take us a long way. So now we know where we stand. Let's talk about what needs to change. And here I'm going to talk a little bit about one of my most favorite things, shift left. Shift left all the things. So let's take a look at how software is generally built. So you would have requirements gathered. Maybe they're going into Jira, and the developer reads that, starts writing code. That code is built in your internal developer platform, in your CI/CD, your version control. You put it into your dev environment. Then maybe you are doing QA, there's a separate team doing QA, and that goes to staging, and finally, you promote it to prod. And prod is like sunlight for bugs. They soon start coming out as soon as things hit prod. And shift left wants all these bugs not to be found out all the way to the right, but we want it to be pushed, the discovery to be pushed all the way to the developer's laptop. Sounds familiar? This is nothing new. People who are familiar with extreme programming, test-driven development, pair programming, you have done this before. Instead of writing the test after you have written the code, you write the test first, and your code is written to that spec. Then pair programming. Instead of waiting for people to review your code, you pair up with someone, and you get instant feedback so that the review time, the time for which your PR sits in review, that goes down. And we take this and see these principles from the right to all the way to the developer's laptop. How can we use that? So deployments, big part of getting your code to production. So blue-green deployment, where you are switching between the live and the thing that you are trying to promote. And then if something goes wrong, you can easily switch it back. Canary deployment, instead of rolling out to all your users, you limit the number of users who are impacted. If things go bad, you switch it back. Synthetic monitoring, here you simulate the behavior that your users are going to do through some scripting. Feature flags, this allows you to roll back features instead of doing a big deployment with the use of these flags. And lastly, chaos engineering, that's popularized by Netflix, where you purposefully inject fault into a controlled environment. You see what things are failing, and then you take those learnings, push it back to your non-prod environment, and try to make things better. Next, observability. Without observability, it's like driving in the dark with your headlights turned off. My boss always says, your customer cannot be a part of your monitoring stack. Your alerts have to be actionable. Something blows up, it has to notify you. But dashboards are not that thing. You cannot be staring at a dashboard all the time waiting for something to happen. So, but dashboards are really good at debugging. All the logs, metrics, traces, they should all feed into your dashboard and help you triangulate where in your whole microservices architecture there is the bug. But that's not enough. You have all these, but you have to do periodic reviews. Maybe you were a startup when you had set those thresholds, and then you had that hockey stick growth, and now you have a lot of users. Your systems are under a lot more pressure, so now you need to review your metrics periodically. You need to review the thresholds that you had set. Developer experience is critically important. Happy developers ship better code. Container technology has made it possible to bring a prod-like environment and spin it up in the developer's laptop. Anybody who's using VS Code and dev containers, you know how amazing it is to have all the components of your stack right there when you're writing tests. Pre-commit hooks for linting, code quality checking, security scanning, these can prevent bugs going into, even before it reaches your CI system, even before you do the git push. And lastly, meta prompts. All of us are now using copilots. So meta prompts are files like claude.md where you can tell your LLM that you are using what are the things that you as a team think is important. What are the things it needs to take into consideration while generating the code. So that brings us to the question, is the developer's laptop the final frontier of shift left? The answer is, it depends. Because the bugs that happen even before the code is written is not the bug in your code base. It's a bug in the culture. It tells you about a lack of honest communication. It tells you there's a lack of trust within the teams. It tells you there's a lack of empathy. Whenever there is somebody under a crisis, are you lending out their hand to help them? This brings us back to the story of ant intelligence. The team has just finished their postmortem, and they have come up with who does what by when. Let's take a look what the teams came up with. Now, in the short term, the SRE team got fixated with disk alerts and runbooks. They would be sending out notifications if the disk is filled up to 85%, and the runbooks gives you easier way to clean up the disk that can be used by L1 support and have problems solved much faster into the problem. The data team realized their testing procedure wasn't good, and they did not have enough error handling, and they needed to move that out-of-band job into Airflow, into a single stack, into a single code repository so that Copilot has all the visibility. The UI team decided to improve on their signal-to-noise ratio, refactoring the third-party library errors. And the C++ team was still at CPBCon, so they could not come back, so people decided that their rotation calendar needs to be updated. That was the short term for them. In the long term, the SRE team decided to focus on sending out release notification and detecting drifts in the environment. This will increase the deployment frequency. The C++ team realized their builds are taking very long time. That's why their releases get pushed all the way to the weekend, making the UI team very unhappy. So decided to reduce their build time by 5%. The data team realized they did not have accurate representation of data in production, in non-production, so they would refresh their non-production databases with a snapshot of prod data. The UI team decided to implement synthetic tests so that they could do pre-release validations and catch errors even before the users got it. So in closing, a bug fix is rarely a code change. A bug's life is a lesson in software development. We need to ask ourselves continuously, what else needs a patch? Is it our architecture? Is it our processes? Or is it us? Technology will always keep moving faster than we can keep up with it. Crisis will always be a part of software development. How we respond to change and crisis will define us and define our products. So let's be a little kind to each other and also to ourselves. Thank you so much.
Thank you. Thank you, T, for your presentation. We have about 5 minutes left. Anyone has any questions? Okay.
Thank you for the talk. I guess I'm kind of curious about your workflow that you had, where like when you have a Jira ticket and somebody starts developing, can you comment on why there is not like a loop between, like before you commit, shouldn't you be debugging? Like, shouldn't that be like a loop instead of?
The bugs, I really wanted to draw this diagram, that's why I did not do the loop, that the bugs, I asked ChatGPT to give me all the emojis of the bugs, and the bugs are jumping back to left. And this loop is really, really important. It's not only just about bugs. Your documentation, everything has to go through an iterative process. And yeah, thank you for pointing that out. I'll definitely make edit to the whole process.
Is there any different process you would take debugging a production environment that's actively losing the company money and you're kind of on a timer versus when you would be debugging in development?
That's a really great question. And again, I'll go back to the shift left aspect to it and the deployment aspect to it. So firstly, having easier controls where you can, something like feature flag, where you can reduce the parts of the code that is causing the problem. If you can triangulate it with all the tools that you have deployed, your traces, your logs, metrics, and you can turn it off, that the code path is no longer getting executed, that would be the damage control. But in your non-prod environment, in your pre-prod environment, you really want to invest in something like dev containers where you can try to, or there are so many Kubernetes versions these days where you can set up a prod-like environment in the developer's laptop. And even though it will not give you the 100%, you still have a safe environment where you are being able to test things out and not break things where you're actively burning money. So it has to be a concerted approach where you have enough tooling in your production so that you can cut things off when the fire starts, and then your non-prod environment is where you are actually doing all the tests, the destructive tests. Great question.
Any final questions, thoughts? All right. Oh, you have another question?
Another question is, can you talk about maybe recommendations on how to kind of bridge the gap between developers and domain experts? Because I feel like a lot of times when you're writing unit tests, as someone who doesn't know the domain itself, you might miss stuff. So can you comment on that? Like, how would you bridge that gap, and especially given, it's time intensive and also brain intensive and like basically all the resources?
Yeah, it is very difficult, and we have been through cases where it takes time. It's just, that's where the communication part comes in. The domain experts and you as a developer having that honest communication, and then you are moving towards, they have to adapt certain tools. We tried BDD with our SMEs, didn't really work, but ultimately it has to be that communication and trust where they are telling you what that spec really means, and you are also actively learning. So it's a give and take. It starts over there. And then there are tools like BDD, like Cucumber and all, where it allows you to write the language, which they understand, and then map it back to a test failure dashboard. But with the LLMs coming into picture, things are going to change rapidly. So we are, it has changed rapidly. So product owners are now being able to generate POCs or proof of concepts, which can be an active model that you can play around and get a sense of what the product they have in mind, and then you make it more robust with your engineering principles. So those might be two